So, today we're going to dive into something absolutely mind bending. It's a breakthrough from Dr. Takuya Isomura over at Riken that might just solve the puzzle of intelligence itself. He's figured out how to unify the three biggest theories of how our brains work, and believe me, it pretty much changes everything.
This has been one of the biggest questions in neuroscience for decades. We've had these incredibly powerful theories, but they always felt like they were describing completely different things. Is the brain some kind of physical machine, or is it more like a predictive statistician? Or maybe it's just a universal computer? The wild part is, the answer seems to be, yep, it's all of them.
All right, here's how we're going to break it all down. First, we'll meet the three major players, the big ideas about brain function. Then we're going to get into why bringing them together is so absolutely critical. After that, we'll get to the big reveal, the discovery of triple equivalence. We'll see how this lets the brain copy algorithms, why evolution itself chose this path, and what it all means for the future.
Okay, let's get into it. To really get what this breakthrough is all about, you first have to understand the three main theories. I want you to think of them as three totally different descriptions of the same mysterious character, each one capturing a different piece of the truth.
First up, we have the dynamical systems view. This is kind of the nuts and bolts perspective. It looks at the brain as a physical machine, plain and simple, governed by the laws of physics. All the interactions between neurons can be described with really precise math, almost like a fantastically complex clockwork mechanism. Second, we've got the brain as a statistical inference engine. Now, this idea comes from something called the free energy principle, which basically says the brain's number one job is to avoid surprises. It's like a superpowered weather forecaster, constantly building models of the world, making predictions, and then updating its whole understanding whenever it gets something wrong. It's all about making the world as predictable as possible.
And our final suspect, the brain as a Turing machine. This is the computational view. It treats the brain like a universal computer, a biological processor with its own memory that can basically run any algorithm you can think of, from doing simple math to coming up with the most complex thoughts. So, we've got these three huge ideas: the physical machine, the predictive statistician, and the universal computer. The big problem, for years, these theories just lived in their own separate little worlds. But if you think about it from an evolutionary perspective, that makes zero sense. Why would natural selection, which is all about being efficient to survive, go to the trouble of building three completely different systems to do one job? It wouldn't. It would build one elegant, integrated system that does it all.
And this is where the story takes a huge turn. Dr. Isomura didn't just find some weak link between these theories. No, he proved with pure mathematics that they were actually just different ways of describing the exact same underlying thing.
And that's the big punchline. They aren't three separate theories. They are one. The brain as a physical system, as a statistical engine, and as a Turing machine are, in certain neural circuits, mathematically identical. They're just three faces of the same powerful entity. What's really wild is how perfectly the brain's biology maps onto the parts of a computer. The theory shows that neural activity, the firing of neurons, that's the processor state. The synapses, those little connections between neurons, they act as the computer's memory. The output neurons are what read from that memory, and synaptic plasticity, the brain's amazing ability to change those connections, that's how it writes new information. It's a perfect one-to-one translation. So what does this actually mean? Well, it's huge. It means our brains aren't just stuck running a single fixed program. By changing their own wiring, they can effectively read and write new programs, which lets them learn and imitate pretty much any algorithm they run into out in the world. And hey, this isn't just a cool theory. They actually ran a simulation where a virtual neural circuit was just exposed to an algorithm for addition. And through a process that works just like natural selection, the circuit spontaneously rewired itself to perfectly copy the adder. It literally taught itself how to do math just by watching.
But of course, this brings up the ultimate question: why? Why would evolution go for this specific, unified design? And the answer really comes down to survival. Having this triple equivalent structure is simply the most powerful and efficient way for an animal to predict, compute, and adapt in a really complex and constantly changing world. This quote from the research paper, man, it just nails it. It connects the biological process of evolution with the mathematical process of learning. What it's really saying is that evolution itself is a kind of computation happening on a planetary scale. Let's break that down. On one hand, you've got natural selection, which picks out individuals that are best suited to survive.
And on the other hand, you've got this statistical idea called Bayesian model selection, which is just a fancy mathematical way of picking the best explanation for some data. The incredible thing is that these two processes, biological evolution and statistical learning, are mathematically the same thing. Evolution is running this massive optimization program, selecting for brains that become the best possible prediction machines for staying alive.
So, what's the big takeaway here? What does this all mean for the future? Well, this unified theory doesn't just solve some ancient puzzle. It hands us a brand new blueprint for thinking about intelligence, both artificial and our own.
What this all boils down to is that the brain has this unbelievable flexibility. It's not just a computer running one program. It's a computer that can reprogram itself on the fly. It can look at the world, figure out the hidden rules that are making things happen, and then just adopt those rules for its own use. This really points the way toward a truly universal, self-organizing intelligence.
And that leaves us with one last, really fascinating question to chew on. If our brains are truly universal learning machines, constantly grabbing and adopting new programs from the world around us, it really makes you wonder, doesn't it? What other computational marvels are we still capable of? What unknown algorithm will our brains learn next?